We are going to start the lecture on nanotechnology in chemical engineering. So, today we will discuss about synthesis of the nanomaterials. So, today we will discuss basically the zeolites. So, how the zeolites can be prepared, and so what are the properties of zeolites and what are the various places of applications are there, the zeolite materials which as a catalyst or other applications. So, that we will discuss. So, zeolites basically it is represented by or expressed in terms of ZSM5. So, it materials it is consist of silica, alumina mainly, that is the structural metal elements present. Apart from that also some other metals also may be present depending upon the preparations or percentage the different metal ions we can use. So, basically silica and alumina, that is the structural component that is present in zeolites. Apart from that, sodium hydroxides, tetrabutyls, ammonium bromides, and so waters, these are the reactants, sodium aluminates and silicon dioxides, the starting materials that can be used to prepare the zeolites materials. Once it is forms a specific temperature and pressures we used, with that analcime, alpha quartz, or that is also silica, basically that would forms in this particular process. And these materials actually commonly used for many applications in chemical engineering point of view. It's used as in adsorbents, catalyst materials, support of the catalyst. So, these type of materials commonly used many chemicals industry where we need to use as a catalyst materials for specific reactions. So, there's we can use zeolites as a materials. Also, these materials used as a molecular sieves, that is known as molecular sieves, since these materials consist of the microporous materials. Pore structure is less than 1 nanometers or 0.3 to 1 nanometers. These materials more pores, smaller pores is present more. So, already you have discussed that aerosol type of materials or mesoporous type of materials, those materials having micropores, aerosols materials having micropores are present. So, even that micropores also means 2 to less than 2 nanometers in case of the aerosols. So, whence that micropores are present in a materials having less than 1 nanometer, 0.3, 0.5 nanometers. So, then or smaller pore than aerosols, then zeolites materials that consist of smaller nano micropores are present. And also the materials is highly ordered materials, this materials is highly orders, and then well defined channels, cavities that is present in this particular type of materials. So, I said these materials, the zeolites, that is main component is silicon and alumina. These are the two metals elements that is present for these zeolites. So, building blocks of the tetrahedral units of silicon and alumina, both in a tetrahedral networks structure formation is there. Silicon oxide, tetrahedral oxide, aluminum also tetrahedral oxides, both are interconnected to tetrahedral interconnected with oxygen bonds. So, these types of bonds are present, silica, oxygen, silicon type of bonds are also present in this particular structures, but there is no alumina, oxygen, alumina bonds does not exist in this type of zeolite materials. So, general formula that is used, alumina, silica, I said, and the frameworks that is subunits is like this. Okay, this is also aluminosilicates you can see. Okay, so here I said this is tetrahedral silica, tetrahedral alumina. So, these units, two units are present. So, basically these are the two primary building block, means units are present, tetrahedral units, and they are connected with oxygen atoms, and therefore they forms a three-dimensional rigid frameworks or structures that would forms. Okay. Sometimes that molecules in the structures that would forms negative framework charges are present. So, when Si plus 4 is substituted by alumina, so then due to the charge balance sometimes negatives charges are present in that particular zeolite frameworks. Okay. And naturally the zeolite materials whatever, so that is present in natures also, or synthetically also we can prepare in labs, whatever it is present in naturally. So, that terms such modernites or clean up tellurides, or these two materials naturally exist, and experimentally or lab also we can prepare zeolite Ca and zeolites X are different type of depending upon their structure, silica, alumina precursors ratio, and temperatures, pressures. Depending upon that methods, the structures would be different. Okay, so these zeolite structures, as a result, they are named differently. Okay, so here's primary building units and secondary buildings units, I say, that actually determine the structures of the zeolites. So naturally acids, these and modernites, these two levels, and apart from that, different type of structures and zeolites are exist, and that is primary units. This is the primary units and this is primary units. So both when coupled with this another oxygen atoms is present in between two tetrahedrals and connected, then it is secondary buildings elements or units, we can say. So this is the different structure that has been reported. Okay, and inside of these structures, so that type of channels or pores is present. That pore sometimes different type of micropores are present, I said, these zeolite materials. As a result, that can be applicable for various organic synthesis or transformation of one organic compounds into another. Isomers or compounds can be prepared that can be used as a catalyst. Okay, so here's in zeolites ZSM5. So it is the full name. So you can see aluminosilicates zeolites. So here these type of pentasils units are present, ZSM5. So 5 members rings are present. So it is this top view, this is side view, this is top view. So this type of means structures or geometry is present, and alumina and silica, whatever the metals is present with or connected with oxygen. So they are distributed, and there this type of structures formations is there. Here the zeolites A and zeolites P types, two different type of means frameworks. Here you can see these two depending upon their method of preparations, I said. So different type of microporous zeolites with forms depending upon their method of synthesis. So here's the structural subunits also here is shown and zeolites. So here we can say that different type of zeolites we can prepare by heating the solutions that we have prepared from primarily alumina and silica, that was the precursors, or you can say these are the oxides present in that zeolites. These are the two metal cations. Okay, these are some organic additives also we can use as templates, and these organic additives act as templates for developments of the zeolite structures. Here the amounts of the alumina and silica ratio we can change, silica oxygen water ratio we can change, cations or silica ratio, organic additives concentrations, pH, many things we can change, and depending upon their means experimental conditions that we are using while we are preparing zeolites. So many surfactants or templates whatever we are using, that may be organic, inorganic, that we can use. And I said in these methods also we have to use high pressure reactors, that is called autoclaves, that we can use. So for that using that reactors we can maintain extremely high pressures when that reactions will take place. So 10 to 100 watts we can use, and temperatures 100 to 350 degrees centigrade we can use to prepare this type of materials. Okay, so depending upon that experimental conditions, temperature, pressures, and surfactants, inorganic, organic reactants. So the pore size also, distributions also would be changes, or that would be different. So selective means the cost of that materials, whatever the zeolites. So we have to prepare means in lab scales or industrial we can prepare that materials. So selections of the raw materials is very important, and depending upon that the cost also of that materials whatever we have prepared, that depends on the materials whatever we use. Okay, whatever the zeolites will prepare from industrial point of view, that should be cost effective and readily available. That materials should be high purity and capable of producing high yields, means of whatever the precursor starting materials you have taken. So means if we want to minimize the cost of that materials, then and also high yield high purity materials, if you want to prepare that materials, that is very important. And selective for desired zeolite structure, so the structures is also important. So many factors, means when we are preparing that material, so many factors associated with that. So depending upon that a particular specific structures if you want to prepare for a specific application, so many things we have to keep in mind. So, okay, So while we are preparing that material, so here's many methods are available for preparation of the zeolite. So solvothermal method, that is hydrothermal or inothermal method also you can say. So alkali fusions methods are available, alkali leaching methods are available, Solz's methods already have discussed. So these are the methods, various methods are available. So in servothermal methods, so in this particular methods, the solvents we can use alcohols, ethylene glycols. So that these are the organic solvents that we can use when we prepared the zeolite materials. Here's high pressure reactors we have taken, and see after that, so we can use either waters as a solvents, or we can use organic means alcohols or ethylene glycols. These are the means solvents we can use, or maybe ionic liquids that can be used as a solvents for preparations of that zeolites by using solvothermal method. So in this case, if it is use waters as a solvents in a autoclaves, so then we can say it is a hydrothermal methods. If it is use ionic liquids for the preparations of zeolites by using high pressure reactors, so then you can say it is inothermal methods or hydrothermal method, or solvothermals, any solvents, organic solvents we can use. Basically depending upon that solvents we are using, so we can classify it is either hydrothermals, inothermals or solvothermals method. So an alkali fusions method, that is also another types of method. So in this case, basically the formations, when the zeolite formations is there, so here's the raw materials we can take, and after that sodium hydroxide we have to used in a fusion tanks, and then fused mixture should be put inside of that autoclaves, and then we have to treat hydrothermals 100 degrees centigrade for 16 hours. Then so we have to do some washings, cleanings, filtrations, and then dryings we can get that specific zeolites materials that we can synthesis. Here we can silica alumina ratio we can change, concentrations of the alkali we can change, temperatures, crystallization rate or times we can change. So these are the various factors that would be affected when we are preparing the zeolites by using alkali fusions method. So here we are putting basically alkali, and that is during thermal hydrothermal treatment. So in autoclaves the zeolite structures would be different. Okay, so alkali leachings also methods, that is leachings maintains means whenever we are preparing or using silica and alumina, two precursors to prepare the zeolites. So here's at some stage alkali also will be used, sodium hydroxide solutions, but some portions of that we have to separate out from that. This is actually sodium hydroxides we can use, and then at particular points we can list out sodium hydroxides or sodium silicate, means by that way you can control the silica alumina ratio, means when base will react with silica, sodium silicates will forms, that we can take out. As a result, this ratio we can control by leaching out methods. So and finally this way we can get that product similarly by putting in a autoclaves and maintain high temperature and pressure. So we can get the zeolites, their silica alumina ratio will be changes. And next is the Solz's methods, that also similarly I said, means precursors you have to take inorganic precursors, and then you have to make solutions and then gel formations, and after that the gels will be heated up or calcined and at different temperatures. So these particular zeolites will be formed, that zeolites we can prepare. Another one is microwave assisted methods, that is also similarly here's heatings of when the gel formations is there. We have to start from raw materials or precursors, formation of solutions, and then formation of gels, and after that we have to heat that gels with the help of microwaves. So and then there would be nucleations and crystallizations of the growth, and finally we can filters and wash and remove different organic materials, and then products will come, so that we can seed zeolite materials that would be forms. And here's also the energy that is transferring in the gels, that is microwave heatings. So here the some property also would change by when we are synthesizing the zeolite material by using conventional seating methods. Instead of that, if we use microwave heating methods, so then structures should be different. Okay. So next is the application. So I said the zeolite materials having microporous materials. So pores is very low, smaller diameters, 0.3 nanometers, to 1 nanometers. So very small porous materials is there. So therefore the nanoporous materials may be apply or gas purification units, there we can use energy storage systems, water treatments we can use, petroleum refinings where fluid catalytic cracking catalyst as a catalyst materials we can use, pharmaceuticals industry there's delayed drug deliveries, there also it can be used. Also widely used this particular zeolite materials as a catalyst in these are the various applications where dewaxing of naphtha, isomerization of xylenes to paraxylene formations, transalkylations of xylene to or toluenes, methanol to olefin productions, methanol to dimethyl ether productions, pyridines to acetaldehydes, pyridine to formaldehydes. So many petrochemicals industries where these zeolite materials can be used as a catalyst. So that can be used. Okay. So let's I said it is a silica alumina network. So sometimes bridge hydroxyl groups are present. So presence of theirs this actually some this type of acidic groups or bronzed acidic sites are present, so that sometimes helps in specific reactions, this type of reactions. Here's one isomerization reactions where xylenes to orthoparaxylenes, so we can isomerization reactions where zeolites can be used as a catalyst. So this is our starting materials, here we can use zeolites. So this the products we can prepare by using zeolites, means this isomerization reactions can help by zeolites. Okay. So here's disproportionation reactions also where xylenes to toluenes or trimethyl benzenes can be prepared. So here we have taken initially metaxylenes. So metaxylenes in using some catalyst or zeolite catalyst we can prepare toluenes, and trimethyl benzenes also we can prepare. So isomerization reactions is said. Okay, so some ethyl acetate was synthesized. This is ethyl acetate. Ethyl acetate. This is ethyl acetate that can be prepared by using zeolites as a catalyst. So here zeolites was used as a catalyst. So here acetic acid and ethanols, that was the starting materials reactants, and this is basically esterification reactions. So in presence of zeolites, so this type of ethyl esters we can or ethyl acetate we can prepare by using zeolites as a acts as a catalyst. Okay. Here's biodiesel productions, transesterifications, esterification reactions where zeolites sometimes are used as a catalyst. Okay. So this is fatty acid, free fatty acids, and this is alcohol. So this is ester formations. So here triglycerides was taken, so alcohol was taken in presence of zeolites. They will gives and forms these alkyls esters. Means here's ester, this is also ester, this is also esters, but here's glycerol esters was there. This is the ester groups, these are the presents. So that would be replaced by RO groups. Okay. So there are some other applications also where this bronzed acid groups that may sometimes means different lactic acid to lactide formations or to methylfurans to acetyls methylfurans formations. Many applications are there. So where these materials can act as a catalyst materials, or sometimes that materials zeolites may be taken as a support materials, and there's different metals that are metal oxides acts as a catalyst for specific reactions can be distributed. That metals atoms may be distributed surface or maybe inside of the pores depending upon that concentrations that precursors was taken. So that would be that specific metal precursors zeolites we can prepare. Okay. So here different way of structures and special distributions of the metals, metal oxides that we have taken for in the zeolites, that may be this way it may be distributed or maybe segregated way distributed, or maybe redistributed, different greens and yellow metal atoms may be distributed like this way. Okay. So also water purification, these materials can be used in wastewaters. There are present various metal ions, organic pollutants, heavy metals are present. So zeolites can be used as a separations of those heavy metals, organic pollutants or metal ions that are present in wastewaters. So these are the various applications. So this is organics pollutants, means when zeolites you have taken that is modified with surfactants, cationic surfactants. So this is basically zeolites, let's say, and see here this is surfactant. So zeolites was modified with surfactants, and that can use to remove this type of organic molecules that is present in wastewater, or maybe some cations are present that may be removed by using zeolites, or maybe some this is anions are present, or maybe some cations are present in wastewaters or waters. So if we modify the zeolites with some surfactants, cationic surfactants, anionic surfactant, depending upon that, so we can, depending upon that application. So here's cationic surfactants was used, that can be used for separations of cations, anions or organics from means from wastewaters, or that pollutants we can remove from the wastewater. So these are the various applications we have used, discussed. So means what is zeolites, how that zeolites can be prepared, and what are the various applications of the zeolites in terms of catalyst or various applications that we have discussed. So today is up to this. Thank you.